our group would like to discuss a topic which is techniques of differentiation. So, what are the questions? Let's take a look. That is an interesting question. Let's start with Aril.
Hello everyone. Now I would like to discuss about the question one, which is the question is explain the meaning of differentiation and what are the techniques of differentiation. First, we need to know the meaning of differentiation and the geometrically way, which is differentiation is the process of a finding slope of the tangent line to curve y equal to fs at a specific point. And number two, we need to know in mathematically way, which is it represents the instantaneous rate of change of a dependent variable y with respect to an independent variable s. The definition is derived from the limits of the slope of a secant line as the distance between 2 points, which is delta s or h, approaches 0. For example, f prime s equal to limit h approaching 0, fs plus h minus fs over h. Okay, now let's we talk about the techniques of differentiation. We have 5 techniques of differentiation, which is number 1 is power rule. We use it for basic function, where d over ds as power of n is equal to ns power n minus 1. Number 2, we have a constant, multiple, and sum, or we always known as a difference rule, which is we use when differentiating a constant times a function or terms spread by addition or subtraction. For example, d over ds, fs plus minus gs is equal to f prime s plus minus g prime s. Number 3, we have a product rules. We apply it when a function is the product of the two separate terms, y equal to uv formula, which is dy over dx is equal to u dv over ds plus v du over ds. And then let's go with a number 4. We have a quotient rule. We apply it when a function is the quotient of separate y equal to u over v. The formula is dy over dx is equal to v du over dx minus u dv over dx and over v power of 2. The last one is number 5. We have a chain rule, which is we use for composite function, a function which is a function inside another function. The formula is dy over dx equal to dy over du multiplied with du over dx. Okay, now let's discuss about the question number 2, which is we are asked to find the dy over dx for the following function, which is y ln x squared then x minus 3. Before we jump into the maths, let's analyze the structure of this function. As we can see, this function is a product of two distinct terms, a logarithm function, ln x squared, and a trigonometric function, then x minus 3. Because these two terms are multiplied together, our main strategy here is to use the product rule. Just to remind everyone, the product rule formula is dy over dx is equal to u dv over dx plus v du over dx. To make this easy to solve, let's break it down into two parts, u and v. First, let's look at the left side. We will let u equal to ln x to find du over dx. We need to apply the chain rule because there is an x squared inside the natural log. Differentiating the logs give us 1 over x squared, and differentiating the inside function x squared give us 2x. When we multiply them together and simplify, we get du over dx is equal to 2 over s. Next, let's look at the right side. We will let v equal to 10s minus 3. By applying the chain rule here, the derivative of the inner function s minus 3 is just 1. So our dv over dx is simply dv over dx is equal sec squared s minus 3. Now that we have all four pieces, u, v, du over dx, and dv over dx, we just need to substitute them into the product rule formula. This will give us dy over dx is equal to ln x squared multiplied with sec squared s minus 3 plus 10s minus 3 multiplied with 2 over s. For the final step, we just rearrange the terms slightly to make the final expression look neat and professional. Therefore, our final answer for dy over dx is ln x squared sec squared x minus 3 plus 210 x minus 3 over x.
Good day everyone. Now, I will present my solution for question 2b, where we need to find the derivative of y equal to x power of 2 plus 1 over cos x. So first, we need to identify the method. So, because this function is a fraction, I apply the quotient rule, which is divide as dy over dx equal to vu prime minus uv prime over v power of 2. After that, we need to divide the terms. From the function, I identify that u equal to x power of 2 plus 1, which give u prime equal to 2x. Also, v equal to cos x, which give v prime equal to negative sin x. Next, we just substitute this value back into the quotient rule formula, which is you can get dy over dx equal to cos x multiplied by 2x minus x power of 2 plus 1 multiplied by minus sin x over cos x power of 2. And finally, we just simplify the numerator by distributing the negative sign, turns the middle operation into an addition. This leaves us with the final answer, which is dy over dx equal to 2x cos x plus x power of 2 plus 1 sin x over cos x. So that's how I solved the question 2b. Thank you.
Assalamualaikum and hi everyone. Today I would like to solve the question 3. First of all, let's take a look the question 3 that given to us. The question 3 that given is the ln y plus cos squared bracket to s squared plus e power to y equal to 2xy. First thing first, we need to find the goal that we need to find. The goal that we need to find is dy over dx. So the first step is we need to differentiate each terms on the both sides. So we go through the first terms is the ln y. Ln y we can use the chain rules. So we just write ln y with respect to the x. So we get 1 over y dy over dx, and then we go to the second terms is the cos squared bracket to s squared plus e power to y. In this term, we must they have a 3 steps layer that we need to differentiate. First, we just bring the power of 2 to the front, and then we get the 2 cos s squared plus e power to y. And then the second step, we just use we must differentiate inside layer, which is the cos squared cos bracket to s squared plus e power to y. If we differentiate the trigonometric function, we get the negative sin s squared plus e power to y. And the last step, we must differentiate the innermost layer, which is the angle. So s squared plus e power to y, and then we differentiate, we get the 2s plus e power to y dy over dx. And then all this differentiate, we just combine to one equations, and then we get the negative 2 cos bracket to s squared plus e power to y sin s squared plus ey multiply 2x plus e power to y divided over dx. If we notice that they have a 2 cos theta sin theta, in this we know that this is the formula of the double trigonometry identity. So we just use this formula, and then we just simplify, and then we just write down negative sign 2 bracket to s squared plus e power to y multiply 2s plus e power to y divided over dx. And the third terms 2s, right? We can use the product rule. Product rule, they have one formula that I just need to use, which is the uv prime plus vu prime, which is we must split the 2s into u, y into v. So u equal to s, u prime equal to v equal to y, v prime 1 multiplied dy over ds, and then all these terms we combine to this formula, and then we get these equations. And then 1, 2, 3 that we differentiate, we just combine to the one equations, and then we get this. And the next step, we just write down 1 over y divided over dx minus 2s, and do not forget that the second term we can multiply again, and then we get the negative 2x sine 2 bracket to s squared plus e power to y minus e power to y sine 2 bracket to s squared plus e power to y divided over dx equal to 2s divided over dx plus 2y. And then the next step, we just split the term that have a dy dx to the left side, and then the term that does not have a dy dx to the right side. And then the next step, we just factorize dy over dx bracket to 1 over y minus e power to y sine 2 bracket to s squared plus e power to y minus 2x equal to 2y plus 2s sine 2 bracket to s squared plus e power to y. And then lastly, we just leave alone dy over dx, and then we take this equation to the right, and then we divide this equation to this equation, and then we get the final answer. Now, I will discuss last question. For question 4, we use linear approximation to estimate the value of this equation. First, we let fx equal to x to the power of 2 minus 1 over cube root x, and then we rewrite into index form. Next, we need to differentiate fx using power rule. So, we need to solve f prime x equal to 2x minus negative 1 over 3 x to the power of negative 4 over 3. Then, we need to bring this expression into normal form of this equation. Next, we need to find the delta x. For the formula of delta x is x minus x0. X, which is given value, is 8.02, and x0, which is initial value, is 8. So, 8.02 minus 8, and then we get delta x, which is 0.02. And then, we need to find the value of fx0. To find the value of fx0, we need to substitute x0 into 8, and then we will get this equation, which is f8 equal to 8 to the power of 2 minus 1 over cube root 8. And we will solve and get 63.5.
We also need to find the value of f prime x0. x0 will also be egg, and then we will need to solve this equation, which is f prime egg equal to 2 egg plus 1 over 3 egg to the power of 4 over 3. We will solve the equation and we get 769 over 48. Lastly, we need to apply linear approximation formula, which is fx equal to fx0 plus f prime x0 times delta x. So we substitute all values we get. f8.02 equal to 63.5 plus 769 over 48 times 0.02. Since this question asks for 2 decimal places, we get 63.82. In conclusion, differentiation is an important concept in calculus that helps us measure how a function changes with respect to another variable. It shows the rate of change and the gradient of a curve at a specific point. By using differentiation techniques, we can determine derivative for many types of functions. These techniques are widely applied in fields such as science, engineering, economics, and business to analyze motion, growth, and changing quantities in real-life situations.